Dear friends, in this video, we will look at odds and probability that play a very crucial role in the journey of logistic regression. And I thought it's a good idea to explain the importance of odds and probability and what are they. Let's now get into some basic equation. Odds and probability, there are two equations. Probability is equal to odds divided by odds plus 1 or 1 plus odds. Odds is equal to probability divided by 1 minus probability. This you should know. In other words, probability has to be between 0 and 1. If you look at the denominator, odds divided by 1 plus odds is bigger than the numerator, and therefore the probability is expected to be less than 1 and greater than or equal to 0. Odds, on the other hand, probability by 1 minus probability, it could be anything. And this is how I would understand the odds, and I hope you will appreciate. Why do you need odds? Because there is a drawback in the ordinary least square regression when predicting the target group. When the target group is of the type 0 or 1, the probability produced by the ordinary least square regression, there is no guarantee it will be between 0 and 1, as we told earlier. Therefore, it will go outside the range of 0 and 1. So if you use odds, it will force the probability to be less than or equal to 1 on the upper bound and greater than or equal to 0 on the lower bound. And the greater than or equal to 0 is achieved by taking the natural logarithm of the regression value. We will see how it works later. So this is the beauty. Odds are used in logistic regression to ensure that the predicted probability always remains between 0 and 1. That's the beauty. Now, let me give you two examples, two simple problems for you to crack. Given the time, you can crack, I'm sure. It's a video lesson, I'm just explaining. These are the odds given here, 0.25, 0.51, 1.5, etc. till 5.0. And probability I given for two entries, and the remaining you will have to fill. So let me show you now. 0.25 is 0.25. Odds is 0.25 by 1.25, which is 1/5. Therefore, it is 0.2. It's already given. Now, the missing entry for 0.5, it is 0.5 divided by 1.5 because 1 plus odds. I'm adding. And therefore, it is 0.33. When it is 1, it is 1 divided by 1 plus 1 is 2, half. Therefore, the probability is 0.5. Now, 1.5 is the odds. The probability is 1.5 by 2.5, which is equal to 0.6000. 2, this will be 2 divided by 3, 0.667. When the odds is 2.5, it is 2.5 divided by 3.5, 0.7143. You can work it out and check the 4 decimal places. Then it is 3.00 is odds. Then the probability is 3 divided by 4, which is 0.7500. When the odds is 5, this is 5.0 divided by 6.0 is equal to 0.833. So therefore, this is the first problem I want you to crack. And we have done the solution. Odds computation, an interesting crosstab. Very often we get in real life. Let's say some medical example. Smoking versus getting disease A. Smoking is yes or no. Disease, getting the disease is yes or no. This is the crosstab. There are 500 people, 200 people are smokers, 300 people are non-smokers. 100 people get the disease and 400 people don't get the disease. Now, the first question is, what are the odds that a smoker will get disease A? What are the odds that a non-smoker will get disease A? What is the odds ratio between 1 and 2? So let me show you the solution and interpret the result for the last part. Now, the first one, what are the odds that a smoker will get disease A, is simply 80 by 120. Because there are 200 smokers, the denominator is same. You don't have to compute the probability by 1 minus probability. You can simply write this as 80 divided by 120. It is 0.667. The second one, likewise, what are the odds that a non-smoker will get disease A, is 20 divided by 280. This is 0.0714. And the third one, the ratio between these two is 0.6667 divided by 0.0714, which is equal to 9.33, 2 decimal places, rounded to 2 decimal places. And let's now look at the interpretation part. The first two are pretty simple. What are the odds that a smoker will get disease A? It is 0.667 to 1 or 80 to 120. In other words, if the odds that a smoker will get disease A is 80 divided by 120, not getting the disease is 120 out of 200, getting the disease is 80 by 200, and therefore the odds are 0.667 to 1. In other words, that a smoker getting the disease, the odds are 0.667 to 1. When it comes to the non-smoker getting the disease, the odds are 0.714 to 1. That's the beauty. It's small. Now, the interpretation of the last one is very interesting. This is, let's say, let me just show you clearly here. 9.33, the ratio between these two. What does it show? It shows that the odds that a smoker getting the disease A is 9.33 times to that of a non-smoker getting disease A, which tells a story. Very high. Therefore, if somebody is a smoker and you have the medical data, you tell the person, my dear friend, you stop smoking or reduce your smoking part, because the odds that you will get the disease is 9.33 times to a non-smoker getting the disease. In other words, you are 9.33 times more vulnerable as a smoker getting the disease compared to the non-smoker. This tells a story, and this is the power of odds and probability, which is the fulcrum of logistic regression. We need to understand this. Thank you very much. We will see you soon in the next video lesson as an integral part of a journey in logistic regression. Thank you very much.